in waterleiding. Ja, daar zo.
Okay. Hi everyone.
Yeah, this is intimidating.
Thank you all for attending this presentation. We're going to give this presentation goes about gas emission management. At BASF, it's very important for us, and for Magion, they have a lot of expertise, so let's go on. First of all, we start with the bigger picture. BASF, the BASF group, is located over all the world. We are #1 in chemistry. We have 239 production sites, more than 100,000 employees, and almost an operational profit annually of 69 billion euros. The most important production sites are the Verbund sites. What's a Verbund site? A Verbund site is a site with a lot of plants where the output of one plant will be the import of the other plant. For this case, this use case, we will focus on BASF Antwerp. The BASF Antwerp is the largest chemical production site in Belgium and the second largest of the BASF group worldwide. This BASF Antwerp covers 6 square kilometers. We have more than 50 plants. These 50 plants are maintained every day by more than 3,700 BASF employees, approximately 1,000 partner employees and 2,000 contractors. All these plants are connected with each other with 65-kilometer road, 54-kilometer railroad, and more than 1,000-kilometer pipelines. We have a turnaround of almost 6 billion euros, and because we are the second largest of the BASF group invests annually in the year 2024 more than 248 million euros. To get an idea of the size of our PI environment, we have 220 interfaces, PI interfaces, which are collecting data over the whole site. And all these data points, the 275,000 tags, will be stored in our PI historian. We do it a long time. So if we go in our PI historian, the first data we have stored in our PI historian is more than 27 years ago. We also do a lot of calculations, calculated PI tags, and more than 10,000 calculated tags, 1,500 PI vision displays, which were built by more than 300 users. The BASF portfolio is divided in 6 segments. As you can see, the BASF Antwerp site delivers the building blocks for 4 of them: the chemicals, the materials, the industrial solution, and the nutrition care.
Okay, this one is from me. Thank you. Well, this morning you had a presentation from Michael from the Batenburg group. So I'm not going to repeat that, just our company. Batenburg Magion is a company of 60 engineers located in 2 places in the Benelux. And we've got 3 departments. The first department is process control, so actually controlling the plants with PLCs and DCS systems. The second, production intelligence, which is my field, and that's getting data out of the plant into a database and do fun stuff with it. And the third, also very important, is cybersecurity. And we're quite a long time active in this field, and a lot of different domains. Well, enough of this. Most important, what you think is the use case itself. So I'm going to hand it over to him.
Okay. Before we started the project, BASF Antwerp already monitored environmental tags, measurements, like the air emission, the CO2 measurement for the site-wide for the ETS monitoring. And for the reporting of this, there are three departments involved: the operations, the analytics, and the environment, climate, and energy. Across the three departments, we stored all the data in multiple systems, like the LIMS is the Labo data, the MIDAS is the environmental data storage, or PI system for the production data, and so on. So there are multiple systems, and to get all this information in one report, it was a lot of manual work that is fragmented, and also the chance of an error was really possible. Why the change? Because we want to be compliant with the new environmental European law, the ETS2 law. Also the fragile manual reporting, because Edward will tell more information about it, but the manual reporting will be gone. And also, before the project, we have an insufficient data ownership, and now we have a really transparent, structured data ownership, who is responsible for which data and will be validated. Main question, why Batenburg Magion? They have a deep expertise in PI systems, proven track record in complex technical implementations. The current knowledge of the European environmental law was for us also a big plus point. Efficient communication, and 6 years ago we did already a collaboration with the migration of our old PhD system to our new PI system.
Okay. Well, we're talking about emissions, gas emissions into the air. But what are we really talking about? Is everyone on the same page of that? Therefore, I'm going to go to a quick overview what it complies. And it's not everything. It's a huge, huge topic with a lot of rules, a lot of regulations. This is just a small speck of it. But first of all, gas emissions, what are we talking about? Well, it's gases that we put into the air which are not too good for our environment. And those gases are examples like these: CO2, SO2, and the NOx, nitrogen, which especially in the Netherlands we hear a lot about it in everyday news. And if we talk about these compounds, we're going to talk about two things: the concentration, so how much of a certain gas is in the flue gas, and the other one is how much. How much did we really put into the air? And that's the main thing throughout the entire presentation, those two. First of all, there's regulation from our governments, and those are done in two different ways. First of all, permits. When you get a permit, you can emit a lot of stuff, but if you go over that limit, you will pay a fine. It's a hard world. If you do bad stuff, you're going to pay. We also have to talk about, okay, that's about concentrations and the quantity. Both can be limited. Concentrations because, you don't want to get all the birds out of the sky, and the total amount is for the entire planet, very important. The second way to regulate everything is a trade market. So each and every company gets a small portion of a country that you can emit. And if you have enough, that's okay. If you have an excess, you can get that excess and sell it on the market. If you don't have enough, you can sell it. You can buy it from the market. But it's supply and demand, so if there is a huge demand but no supply, you're going to pay big time. And that trading is only for a couple of these gases, not all of them. And important, it's only about the quantity, the amount. For the people who don't know that, we call that freight. So freight is a term I'm going to use more often in this presentation. If we talk about emissions, this is the European standard that you have to comply to. Not only this one, but this is one of the big ones. There are a lot of different kind of regulations, but this one really is important. And it's about emissions from stationary sources. So not a car, not a plane, something that stands still, a plant. And like I said, it supports a lot of different rules, regulations, and other norms. So it's quite a big topic to talk about. But this specific one describes three things. First of all is, how do you collect the data? The plant is generating data, but it has to be collected. Well, there's something that's called Pi Data Archive from the AVEVA company. It's a very good system to store your data in. It's the perfect means to store this data. So that one is covered. The second one is, it tells about which kind of calculations do you have to do, and how do you do that. We're going to talk about that later on as well. And the third one is what you got to report. You've got to report to the government, so they will tell you what to report, how to report it, and when. Okay, we're talking about calculations. That's a big part. This is difficult because we're going to talk about a concentration measurement. Let's say CO2. CO2 is measured within your stack, and it's got a percentage. And the concentration measurement has to be corrected. The measurement is calibrated for a certain range, and if you want to have the exact value, then you have to do a calculation. When you have done that, everything that is above 100% will be topped off to only 100%. Because they say above 100% is not possible. Then, a minute average. There's one word there above, valid. A valid minute. What does that mean? Well, a valid minute is an average, a minute average, when your measurement, concentration measurement, doesn't give any errors and you're in normal operation. Normal operation, that means that there is all abnormal operation as well? Yeah, indeed. It's called startup. Look at your car. If it's still a combustion car, if you start it, when it's cold, it will use a lot more fuel and it will emit a lot more CO2. For a plant, it's exactly the same. And the concentrations, if that's measured at that period, each and every time you will go above the actual limits. So no plant will be ever started up. That's why the rules say, okay, only during normal operation, when you're steady, then you have to report your concentration. Concentration, not rate. So, only in normal operation and when the measurement doesn't fail. You've got a minute value. Otherwise, you don't have a minute value. Be aware of that. If the other success are there, there is no minute value. Then we're going to do normalization, because the limit values are based upon a standard gas, so a normal pressure, temperature, not the circumstances in your own stack. So we have to do some calculations to be able to compare apples with apples. So first we have to calculate to dry flue gas. Then standard pressure and temperature, standard oxygen, and we've got to convert it to milligrams per normal cube. Just a couple of calculations. And if you've done that, you can create an hourly average. And the strange thing there is, okay, you've got a valid minute. If a minute is not valid, it's not there. So now the hour average says, okay, you have to have at least 40 valid minutes before you can create an hourly average. If not, that hourly average does not exist. Strange, but that's because if you are in a startup, you don't have to report it. So don't report anything. And with those hourly values, a day, a week, a month, and a year value is created. So maybe a couple of you think, okay, that's fine. If my measurement isn't working, I don't have a minute value, I don't have an hour value, no week values or month, year. I don't have to report anything. Yank the cable out, I'm done. Sorry, no can do. Government thinks of everything. So, this is the concentration, which is compared to limit values out of your permit. Second, the freight, the total amount. Well, first of all, you start, bless you. First of all, you start with exactly the same concentration measurement, exactly the same one. And then you're going to do calibration correction, exactly the same step. But then a validation process. Okay, I've got to talk about that one. What is validation process? Validation process is if your values are not correct, and you have to detect that something is not correct, and then you can use a replacement value, or you can do a manual correction. What you're doing is, if the data is not correct, you're going to correct it. Because we need to report freight every time. No matter if your stuff is working, no matter if your plant is starting up, each and every single gram has to be reported. Everything. So make sure your data is okay. And if your data is not okay, for whatever reasons, you use a replacement value. That's a validation process. Looks the same as with concentration measurements, yet totally different. But after that, we're going to this normal standard normalization and averages over an hour, which uses all minutes because everything is okay. We've also got the flue gas flow. It's a flow measurement, so it doesn't have any calibration ranges, but it does go through the validation process. Exactly the same as the concentration. It has to be normalized. Different calculation, but almost the same. We've got an hourly average. Combine those two, and you've got the freight for an hour. And after that, you can create a day, a week, month, and a year. With all hours, because all the data is there. Okay, now we know what we've got to calculate. Which sequence we've got to calculate it, and how are we going to do that? Well, the solution we found was use the Pi data archive combined with Pi analytics framework, so AF, to create two applications, two web applications. So be aware, the basis of this all is AVEVA Pi. But we got two web applications, and the first of all is the validation tool, We talked about the validation process. You have to got something that sophisticates that. So yeah, what does it do? Well, it detects if something is wrong with your data and will notify you, hey, this data might be wrong, have a look at it. And you have to have the possibility due to the corrections, because we said if those data isn't correct, you have to correct it. So you have need something to do that. It does the calibration correction calculation, the very first calculation. And why did we put it in there? Well, we said the validation tool is all about the measurements. Each and every single measurement is treated there, is molded into something we can use. So this is part of it. And it calculates the minute values, which is, of course, the validated, the ones used for freight. But also, because it's all about the measurements and everything compact in one tool, so also the valid, so for the concentrations. And for the people here who are in the environmental department, it also has the calibration range check. Didn't talk about it, left it out of this presentation because it's a whole other topic. But for those people, it's in there. If you don't know what it means, I can tell you later on, or ask your environmental department. And one of the big features of this is that it also can be used for non-emission data. It's a tool to get your data right. So if you have a production report, you want to have right data as well. This is used for it as well, so it's now multi-purpose. The second tool, emissions. That's the whole purpose of the project. Well, it does a lot of calculations for the concentrations, for the freight, and of course, reporting everything. Reporting everything that is prescribed in the regulation. Because, yeah, that norm states everything. And it also does some detections, because if you're going above a limit, your environmental department wants to know. It's going to cost them. So that's an important part of it as well. So how did we do it? Well, the people who are using the Pi asset framework on top of Pi data archive will recognize this one. This is your data model, is how everything is created in Pi AF. It's the tool we use to contextualize your data, but also add calculations. And if you can see here, there are also error detections there. So all the detections of that data might be not okay, it's in there as well. So if you want to extend it, BASF can do that. Just add another error detection. And then the web application. Well, the web application is based on top of that Pi AF. Pi AF is the engine. It's all the smart stuff is in there. And here, we've got a presentation. The hierarchy on the left is exactly the same. It's from Pi AF. And show you if there is a detection. And if you click on it, it will go to the base. And, well, this is pretty straightforward. We've got a flatliner. And this application will be able to automatically or by hand change the values that are missing and then get real good data. Now to the environmental, so the emission application. That's a second web application, also built on top of Pi AF. But first of all, how did it all work? Well, first of all, we're going to start with the concentration and flue gas measurement. Those are used in the freight calculations I've shown you. So the first calculation is to normalize them. Be aware, those are coming from the validation tool. So every other calculation that is in the validation tool already done. Now the emission tool is going to do the normalization. Standard pressure, temperature, oxygen levels, things like that. So we need other measurements as well. And here you can see that this is different than the validation tool. Validation tool is all about the measurements, and each measurement is treated individually. Here, everything is coming together. Well, we get some minute values, which are normalized. Then hour values. With these hour values, we can calculate the freight. And with those hourly values, we get the day, month, year values. So that's the idea, that's the theory. Where are we going to put it? Well, PIF, of course. It's very good in doing calculations, so these as well. So if you can see here, right again, there's a hierarchy created, especially for getting your information out of it, and all the calculations that are needed to do everything. And yes, some of them are quite easy to read. I'll touch that topic later on. Here's the web application. First of all, on the left, yet again, there is the hierarchy. It's based on top of PIF. So if BASF says, okay, we're going to add other emission points to PIF, it will automatically pick it up. And if you select an emission point, you get all the data. Don't look at the data itself. It's, like I said, fictitious data. I was allowed to show you a lot, but not everything. So here it is. All the data you need to actually go into an audit and report to the government. Everything they prescribe that you need to have. And this is the last slide. Which considerations did we have prior to this project? How are we going to solve it and why? Well, first of all, we needed a separation in concerns. So a validation tool, all about the measurements, and an emission application, which is used to report to the government. And like I said, PIF is the basis of everything. All calculations are in there. Why? Well, PIF is easy to use. It's easy to read, and no program skills. So if there is anything, it will show up. But also, because it's easy to read, it's easy to certify. Yeah, the government says, okay, if you've got a tool, it has to comply with our rules. And you are obligated to show us that it actually does the job it's made for. So there must be a third party, independent third party, to certify a thing. Well, try that with your code in .NET, which is compressed and nobody can read it. In PIF, it's easy to read, easy to validate, and easy to certify. Which we have had, André, at the BP plant, we also did a similar application, and yeah, it's certified because it's easy to read. So PIF does a perfect job for that. Also a very important thing, everything has to be logged. Why? Well, you're gonna get audits. And when somebody does a change in the validation tool, so you do a correction, all the calculations based upon those values has to be redone. And everything someone does has to be logged. But because we do corrections and recalculations, every calculation has to be done as well, and we have to show the auditor, these are the calculations that have been redone. This is the value prior backfill. These are the values after. Complete transparency. And last of all, the rollout. We're now in the phase of rolling out the very first plant, which is quite exciting. And in the future, if BASF wants to, they can do the rollout themselves. It's in BASF. They are the owners of that. They are the ones who can do that, so they don't need us. If they want, we're going to help them, of course, but they can do that independently. That's one of the key factors they wanted as well. Create something that is expandable on our own terms. So that's a small overview of what we did for BASF at Antwerp. Questions? Anyone?
If someone has one burning question, you can ask it now. And otherwise, you also have a booth there, so they can also walk to your...
oh, absolutely, we've got a booth. One thing I do want to mention is that this project also made a shift in data ownership. First of all, the environmental department was completely in control, and they were completely responsible for all the data they reported, but also the data they collected. And now, because we got a validation tool, which is used for each and everything within production, so also production data is used, they are now the product owners. They are responsible for getting the data correct. So that's a different way of working that is introduced during this project as well, which is something you want to think about yourself as well.
If I can begin. Indeed, we have now the right person, right place. So the expertise of the production people is necessary for validating the data, and the expertise for the people in the environment department, they can focus only on the reporting and not only with the pain in the ass Excel every day. Now they can use this tool and they get the figures automatically.
Question?
Yes, wait a sec, because then I'm going to throw it. No, you can throw it.
Dankjewel. What do you do when the O2 measurement goes in failure with the normalization? Because the O2 is for the normalization of your the flight. Can you get a notification to someone or?
Very good question. Indeed, for the people who didn't notice, the oxygen measurement is used for the normalization. So, and standard temperature, pressure, but also standard oxygen. And if that measurement doesn't work, the entire process fails. So what we did is say, okay, in the normalization calculations, the validated value is used. So if that value is incorrect, there is a detection that says, okay, there's something wrong with your measurement. Go have a look at it. And then you can do corrections, and those corrected values are used in the calculations during normalization. So if, let's say, that measurement failed yesterday, and you noticed only now you can do in the validation tool, say, okay, for yesterday, from that time to that period of time, these are the correct values. Check in. It's going back into the Pi database. All the calculations based upon it are redone, and your measurements, your results are updated. And the system will log what those updates are. So if you get strange values and good values after that, within the audit, it will mention, this is the entry in the validation tool, these are the calculations, this was the result prior, this is the result after. Complete transparency. Does that answer your question? Okay.
We had the burning question. I see your timer is almost running out, so I would kindly ask if there are any more questions to... Yeah, throw it, thanks. If there are any more questions, just visit the Batenburg booth. Also for you too, thanks a lot for sharing your story. We've seen the Luik-Natie, which is a similar project, in the video, but this makes it really tangible. And also, I think you did not mention AI at all in your presentation.
Indeed. All of this is based upon actual analytics.
So, I think that proves that we talk about AI, we talk about data, but everybody, does it in a different way. But in the end, it's about the use cases. It's about how to make value of your data, and there was a lot of dirty work in it, huh? So,
and be aware that most of the use cases don't need AI at all. Some of them do, but most of them don't. This is
Thank you.
Thank you.